Pleasure to be here. So how many people work with pears in the audience? And there's a few. Okay, well the rest of you, maybe it's in your future, so we'll teach you a few things for future reference. All right, so we're actually going to talk about European pears as compared to Asian pears, which generally don't need to be ripened after harvest. However, most European pears do not have the capacity to produce ethylene on their own. The fruit have not yet developed that capacity, and they don't develop that capacity after harvest unless they've been exposed to a period of cold storage or they're treated with ethylene. And we call that conditioning, so cold conditioning or ethylene conditioning. And the requirements for cold or ethylene vary by the cultivar or the variety, and also with the maturity at harvest. And of course, we'd like to experience a sweet, juicy pear, but it can be challenging. At least in the United States, our experiences, it can be really challenging to find that in the grocery store. And part of the reason for that is that pears can be a little bit challenging to ripen. They're one of these fruit that really need to be harvested unripe, mature, as you understand now, but not yet ripe. So we know that pears are climacteric fruit, and they're pretty far on that climacteric spectrum in that they really need ethylene, and once they start ripening, they do produce ethylene and show a peak in respiration. But at the time of harvest, the pears don't have the capacity to produce ethylene on their own. Kiwi is another fruit that's similar, but they're somewhat unique among fruit in that respect. So they need us to either store them in the cold for a period of time to allow that process to kickstart, or to treat them with ethylene. And we actually have two different approaches we can use, and it varies depending on the variety of pear that you're working with. And varies with the variety or cultivar, and also with harvest maturity, and we'll go through all of that. So you heard earlier about ethylene and ethylene biosynthesis a little bit, and I just want to point out in this pathway of ethylene biosynthesis, we can see, we start with this amino acid methionine, and you can actually see the ethylene molecule in here. And then we form a compound called SAM, and then we go on to ACC, and then eventually we break out the ethylene molecule as a separate molecule, which is a gas. Well, along the way, there are enzymes that are important for each of these transition steps. And two of those enzymes, ACC synthase and ACC oxidase in particular, are not produced in the pear fruit at the time that they're harvested. So the genes that produce those enzymes aren't activated when pears are harvested. And so what we have to do is kickstart that activation. Now I just want to point out the problem a bit with this data here. So in California, the main variety we grow is Bartlett or Williams. And this is some data showing how many days did it take for the fruit to get fully ripe and ready to eat. And we're looking at fruit from two different seasons, two different regions in California, one very close to here and one more in the north. And then we're actually looking at two different orchards within each region. And so, and then three different harvests. So the first harvest being less mature, the third harvest being more mature. And you can see that in the early harvest, it can take from 12 to 15 days, depending on the orchard, for fruit to ripen. But as we move to later harvest, and eventually to our last harvest, it takes about half the time for the fruit to ripen. And you can also perhaps see that there is also some difference between the regions. So this higher, more northern region, I should say, and it's a little bit in the mountains, takes a little bit less time, even with that early harvest, to ripen. So we don't want our fruit, we don't want to send fruit to retail and have them sit there for 2 weeks, either at retail or on the consumer's shelf, waiting for the fruit to ripen. And I can tell you that for other varieties, it takes a lot longer. Bartlett is actually one of the easiest ones to ripen. So this is the challenge that we have. And so we know that we can overcome this by exposing the fruit to low temperatures. We know from research in my lab that the low temperature exposure induces the activation of genes that then produce those enzymes that we talked about. And so most pears are stored, at 30 to 32 degrees Fahrenheit for long-term storage. And we know, and I have to apologize, I know there's a lot of Europeans here who probably have different varieties. I think a lot of the European varieties are pretty resistant, so they're probably more like an Anjou than any of these other varieties. Maybe a Camise, if you want to try to sort of gauge where you're at. But in any case, Bartlett and Boss take 1 to 2 weeks of cold before they, if you then took that fruit and put it at room temperature, it would ripen in about a week and produce lots of ethylene on its own. The Camise variety needs 2 to 4 weeks, and then the Anjou variety is very resistant and it needs at least 8 weeks, maybe even longer. And of course that all depends on the harvest maturity as well. So to look more at the harvest maturity, we have this data here for Camise and Bosc. So I'll just orient you quickly to the figure. So the data is actually saying how many days of cold storage did we need to get the fruit to ripen well once we warmed it up, okay? So I was telling you on the previous slide that for some varieties it's 2 to 4 weeks, some it's 8 weeks, but it depends on the harvest maturity. So for Camise, if the fruit are harvested at the very beginning of the harvest season, so we'll say time 0, it takes about 28 days for the fruit, 28 days of cold storage, then the fruit can ripen very well after that. But if we delay the harvest 1 week or 2 weeks or 3 weeks from that original date, the fruit's getting more and more mature as we wait longer. You can see that the amount of time in cold decreases. And it can decrease, eventually you can get to a point where you don't need any, but you'd have to wait a couple extra months. And it would probably be too cold, the fruit would be frosted on the tree. So that's not going to be feasible. So in any case, that kind of gives you an idea of how maturity affects things. And then if you look over here at Bosc, first of all, you can see that at the very earliest maturity, it's only taking about 15 days. So that's a difference in how much cold is needed. But you see the same relationship as you leave the fruit on the tree an extra week or 2 weeks, then you need less time in the cold. Now this is some data for Anjou pears. And again, we're looking at harvest timing, starting with the earliest harvest and then delaying by different numbers of weeks. And if we look at this top line, this is similar data to what we saw before. As the fruit gets more mature, it needs less time in the cold to induce ripening. But the other thing that this slide introduces is the impact of temperature. So it's not terribly practical for most operators, but we do know that if the fruit are stored at warmer temperatures, say at 41 Fahrenheit or 5 Celsius, or even at 10 Celsius or 50 Fahrenheit, it takes less time in the cold to actually induce the ability to ripen. And actually the magic temperature is this 10 degrees Celsius, 50 degrees Fahrenheit. We know that at that temperature, it takes the least amount of time to induce ethylene production capabilities than at any other temperature. If you go to a higher temperature, it takes more time. If you go to a lower temperature, it takes more time. So it's kind of a complex graph, but the bottom line is that 50 degrees or 10 works faster than the lower temperatures. So the other thing to know is that the time that the fruit are in cold storage can also affect the quality of the fruit in terms of sensory quality. And that, in addition to just getting the fruit to soften, we also want the consumer to have a good sensory experience. And so this is some older data from Oregon where they were looking at angio pears. And the fruit were in cold storage from the time of harvest and then up to 21 weeks in cold storage at 30 Fahrenheit or -1 Celsius. And they looked at the sensory quality of the fruit periodically during storage. And so the higher the number here, the better the quality of the fruit, okay? So up in this range, the fruit is excellent in terms of eating quality, and here they're unacceptable, okay? And so what you see, and we also have 4 different harvests in here. So if we start with the first harvest, you know, the fruit really only gets into the good range after at least, I can't quite, in this case about 2 weeks of storage, say, it gets into the good range, and then eventually it gets up into excellent. But later harvested fruit will get up to good sensory quality a little bit earlier because it's more mature at the time of harvest. Okay, and then this is just some similar data for Bosc, just to show that actually overall the quality is better and it comes up much more quickly than it did in Anjou in terms of improving in quality. Okay, so that's talking about cold storage. And so if you're someone who's sourcing fruit, if you can educate yourself about when fruit are harvested, so you know how long they've been in storage depending on where you're buying it from, you can have a better sense of how easily it's going to ripen when you get it. So sometimes though we don't have 8 weeks to wait to ripen or to market our fruit. We might want to market them immediately, or we want to ripen them for fresh cut or some other purpose. So we can use ethylene to speed up that process. So this is an example of some Bartlett pears on the top row that were just placed at 68 degrees Fahrenheit, 20 Celsius for 8 days. And you can see the fruit are still green and hard. But if they were given 1 day of ethylene exposure, followed by 7 days at warm temperature, then you can see that they've turned yellow. And if we look more closely at what's happening in the fruit, we find that not only were these still green, but they didn't show any signs of softening. So this is the firmness of the fruit, and it's basically just staying the same. Whereas the ones that were given ethylene have softened to a nice soft level, and it's because they produced ethylene. So by treating the fruit for just 1 day with ethylene, we induce those genes and those enzymes, and now the fruit can produce its own ethylene, and that's what we're seeing here. And so then it just goes on and ripens naturally. Now this data with Anjou is looking at a combination of low temperature and ethylene. So you might remember that Anjou, like a lot of the European pears, is pretty resistant to ripening at harvest. And so in the bottom graph, we're looking at the quality scores in terms of flavor and texture quality of the fruit after different lengths of cold storage. So starting at harvest and then going through to 8 weeks. And the higher the bar, the better the quality of the fruit. So what you can see is that, you know, even at 8 weeks, which is kind of the minimum level of cold storage, the fruit are only about mid-range on the scale. So yeah, they're gonna ripen pretty much, but they're not gonna wow the customer, okay? But if you give those fruit 3 days of ethylene exposure before you ripen them, or as you're ripening them, then you see the scores are higher across the board. And even as little as 4 or 6 weeks of cold storage can give you a pretty good eating piece of fruit. And this is part of the reason why the industry in the Pacific Northwest with their Anjous have gone to a system where they're starting to treat the fruit with ethylene even after extended lengths of cold storage, because studies have shown that that actually increases the flavor volatiles and the sensory experience for the customer. And so they are looking at that combination together. Now, one thing that's important to know is if you're doing the ethylene treatment, the temperature of the fruit during the ethylene exposure is really important. So it's great that you've heard Jeff's presentation about temperature management because particularly if you're taking fruit from cold storage and then you want to do an ethylene treatment, you really have to get that fruit warmed up uniformly so that it can respond to the ethylene. So we've done studies on this with the Bartlett pear, and we know that if the fruit temperature, the pulp temperature is at 68 degrees, we only need a 1-day ethylene treatment. But if the pulp temperature is at 50 degrees or 10 Celsius, we need 2 days of ethylene to get the same effect. And if we're at 45 Fahrenheit or 7.5 Celsius, we need 3 days. Now we don't have this kind of data for other varieties, but I'm almost certain that the relative differences would be similar. So temperature of the fruit is really, really important. Otherwise you could get a really different response and have checkerboarding amongst your fruit in terms of its rate of ripening. So over the years I put together this table that talks about the different conditioning options for the most common pear varieties in the United States. And here we're looking at cold storage. This would be -1 to 0 Celsius. And again, I mentioned these times before. This is weeks of storage. If you happen to be able to store at 50 Fahrenheit or 10 Celsius, you can shorten that time quite a bit. And then if you're trying to do it with ethylene, again, some varieties like Bartlett and Vosk take 1 to 2 days. Camise needs 3 days, and Anjou also 3 days. But if the temperature is lower during your ethylene treatment, then you're going to need more time. And for that, we only have data for Bartlett, but not for the others. Okay, so as you've probably gathered, it's a little bit complicated to ripen pears, right? There's all these things to think about. There's the maturity, there's the variety, how long has it been in cold storage. And so depending on who you are and where you sit in the supply chain, you might not want to have to worry about this. Maybe you want to just work with a shipper who will assure you that the fruit has been conditioned if needed, and let those people at the production end who are harvesting and storing the fruit, they could do the conditioning treatment for you, and you develop a rapport and a relationship so that when you get the fruit, you can just warm it up and it'll ripen and you don't have to worry about all that other stuff. So that's one option. But you want to make sure you develop a really good relationship with your supplier to make sure they're doing it properly. The second option would be to get in fruit. Maybe you know it's early in the harvest season where you're buying the pears from, and then you have your own ripening room and you apply the ethylene. Or even you might want to even apply the ethylene even if the fruit has been in cold storage for a while, because as I said, studies have shown that that actually does enhance the sensory quality of the fruit, and people do notice a difference both in texture and flavor. So you could just control that whole process yourself, and actually it doesn't hurt to use ethylene when you're ripening the fruit. So if you have a ripening room, you can forget everything else I said except for maybe how long it'll take to ripen the fruit. As long as you just put ethylene on, it can pretty much overcome all of those variables that I was talking about. And if you don't have the capacity to treat with ethylene during your ripening, if you know when fruit are harvested, if it's been in cold storage for at least a month before you get it, you can generally get by just warming up the fruit and not having to apply ethylene. Okay, so we've been talking so far about conditioning pears. So this whole discussion so far with ethylene and cold and all of that is just getting the fruit to a stage where they will ripen when you warm them. Okay, so now what happens when we warm them? That's what I call ripening. So I call all the other stuff conditioning or kind of preparation, and now we're into ripening. So, the fruit can be ripened immediately after harvest, after a period of cold storage, or as I said, it could be ripened, at at your processing facility or at a wholesale warehouse, either with ethylene or without. So for ripening for pears, you definitely, the temperature needs to be greater than or at least 55 degrees. So if you're, which is, what is that, about 12 Celsius. If you're lower than that, the fruit really will not soften much at all. So you have to be warmer than that. Oftentimes we use a temperature of about 20, but I'll show you how temperature does modulate the rate of ripening, at least for the Bartlett variety. So this is some data we collected on Bartlett pears, and it does make the case that there's a big change in the rate of ripening. So this is loss in firmness over time, and we have a range of different temperatures. So this is 10 degrees Celsius, this is 20 degrees Celsius. And so you can see that at 10 degrees Celsius, the ripening is really slow. But then you go just to, I think this is 12, 13 degrees, and you get this big difference. So it's a very narrow range there between not ripening hardly at all and ripening reasonably quickly. You can speed it up a bit by going to 20, so this is, ripening a few days faster than these fruit here. So just like with bananas, we can try to control things a bit by changing the temperature, but again, you want the temperature to be uniform or you're going to have checkerboarding. So the last thing I want to say about pears, and Jeff probably mentioned this a bit, but whether we're talking about exposing them to ethylene or we're talking about the ripening, temperature has a big effect. And sometimes it can be really hard to modulate the temperature, especially if the fruit were cold when you started. And the packaging that you use is really important. And I just want to share this data from a study that was done a number of years ago looking at, this is sort of a traditional pear box that has been used in the past, where it's basically a telescoping box with a liner inside and trays, and the only venting is here at these handholds, and then so then we have the trays of pears. So in this study, thermocouples were placed throughout this pallet, and in fact in this case we were cooling the fruit, but warming should be very similar. And I just want to point out that even with a tray packed pallet, some of these pallets took more than 7 days just to change halfway between the starting temperature and the destination temperature. So if you're trying to change the temperature by 40 degrees, it took 7 days just to go 20 degrees. So and it's even worse if you use a hand wrap package, which is pretty common for pears. So you need to use a package that's really designed for good ventilation if you're going to be doing ripening. And I think the pear industry is coming around to this reality, but it's been a challenging adjustment. All right, so just to recap, there are a number of factors that affect the conditioning of pears, the variety, the harvest maturity, the temperature during cold storage, the ethylene treatment, and the fruit temperature during the ethylene treatment. So with that, if there's time, I'd be happy to answer a couple of questions.